The speaker is Sam Frohlich from the University of Bristol.
Hello, everyone. My name is Sam. It's weird using a different computer. And today I'll be reflecting on property-based testing, previously referred to as sort of random testing earlier in the keynote. So I'll talk about how I got into it, its current state, the challenges I see there, and then more broadly in the area of VETS research as a whole. Also, please put your engagement hats on because I have some discussion planned for the second half of the talk. So don't worry, it's not quite yet, and hopefully I can wake you all up, but make sure you're paying attention because I will ask you to speak. Luckily, we've got mics. So to start off with, a little bit about property-based testing and how I got into it. So as opposed to unit testing, where you normally test code with specific examples, property-based testing or random testing tests that property should hold for a bunch of random values. So for example, let's say that we wanted to test that reversing a list twice does indeed return the same list. If you were doing unit testing, you might go, yeah, I'm going to use the empty list, the singleton list, and then some other list. When we use property-based testing, we introduce this X's, so we're sort of general over the list, and then a random generator is going to generate lots and lots of lists to test this property against. So we really like this because it's going to be a lot more thorough than just writing unit tests. It's going to throw so many more examples than you could be bothered writing. And it's gonna, because they're random, it's gonna find problems that you didn't expect. You know, I maybe expect that the empty list might cause a problem because it's different, but the beauty of random testing is it'll find things that you don't expect. Moreover, not only is it just gonna go, this value broke the property, it's gonna go, oh, this value broke the property, let's make it as small as possible and give you the smallest possible example, the smallest possible list that breaks this property to help the tester. And that's what we recall shrinking. I think earlier it was called test case reduction, but another really helpful part of property-based testing. So this style of testing was popularized by Haskell's quick check, and that features its own language for generating values. And the cool thing about this generator language is that it can generate values that uphold some sort of validity condition. So for example, let's say we were testing a property on binary search trees. So that's trees where we've got values at the node, smaller values on the left, and bigger values on the right. So it's much better to test your property against trees that have been generated to be binary search trees, rather than just generating normal trees and filtering them. Because in the latter case, it's really unlikely that a randomly generated tree is actually going to be a binary search tree. So your property is probably never going to get tested. The test will pass, but probably vacuously, without your property actually being tested, which is not what we want. So a generator for binary search trees in this language might look something like this. So quick check generators are monadic, so they've got this gen monad, and you can think of the gen monad as a function from randomness to the values. So this is going to take some randomness and produce trees. So this function that produces BSTs takes the current bounds, the current low and high. When there is no value that could be placed at the node, we just return a leaf. When there is a value that we could place, we make a weighted choice using the frequency constructor. Sometimes we do return a leaf anyway, but sometimes we make that value. So we use the choose combinator and the bounds to make a correct value for the node, and then we use recursion to generate the left and right subtrees, and that's all composed together using the monadic do notation, which is pretty nice. The key thing to notice here is that this generator is baking in the validity condition of what it means to be a binary search tree. You know, we're updating those bounds on recursion. We're enforcing we've got smaller values on the left and bigger ones on the right. So surely it can do more than just generate these values. So I got into property-based testing when I met my soon-to-be collaborator, Harry Goldstein, at the ICFP 21 poster competition. A really great way to meet collaborators if it's not COVID. But it worked out for us anyway. So he was presenting a poster, and we got chatting because it turned out we were both doing work related to the same paper. So my background is in bidirectional programming, and I was currently working on a journal extension of my PhD supervisor and his collaborators' work, the monadic profunctor paradigm of bidirectional programming, or there and back again monadically, as I like to call it. Let me tell you the relevant details as to why I got chatting with Harry. So bidirectional programming revolves around bidirectional transformations, and this is where you've got one piece of code that can be run in two directions and is normally expected to satisfy some sort of round-tripping property. So for example, the related operations could be transforming to and from different representations of the same thing, and the round-tripping could say that going there and back again is going to be the original value that you get back. And we really like this technique because it saves effort. You're only making one thing instead of two. So that saves time and implementation effort. And because you're only writing one thing instead of two, you don't have the risk of them falling out of sync. So the relevant example here that got me into testing was bigenerators. So a bigenerator is a generator that can be run forwards like normal to generate values, but it can also be run backwards as a checker. So it can take a BST and say yes or no, is this a binary search tree? So in other words, not only can this generator generate values, but it can also check whether it could have generated a value, if it could have made it. So Harry had a problem that he wondered if monadic BX could solve. So in property-based testing, as I've said, we really like shrinking. Unfortunately, often shrinking is quite a manual process. So either you have to manually write the shrinker, which is quite a lot of effort because you have to, maintain the fact it's a binary search tree while also making it smaller, or worst case, the shrinker isn't written or you can't write it and you have to manually shrink a value, which is no fun at all. So there are some tools to try and help with this, such as Python's hypothesis library, and they use the generator to help with the shrinking process. But it doesn't quite work in all cases, let me tell you. So consider that you have an analyzer for node packaged JSON files. And let's say a user comes to you saying, my file breaks it. But the issue is, that file is really big. Harry was not happy. So the JSON file is too big, so you don't know what part of it is actually causing the code to fail. Of course, you want to shrink it. And you want to shrink it in a way that it keeps all of the JSON stuff and all of the relevant records, but highlights the bit that breaks it. In this case, this rogue dependency. But you really don't want to do that manually. You want to do it automatically. So Harry had been working on viewing generators as parsers of randomness. So you generate some random stuff and parse these random choices into values. So if we take that perspective, instead of shrinking the final value, we could shrink the choices that led to the value and then regenerate. Because if we regenerate using the generator, that makes sure we're going to definitely have that structure that we want. So this is what Python's hypothesis library does. When it generates a value, it keeps the choices it made. So if it needs to shrink, it can shrink the choices. But our value came from the user. So it doesn't have those choices lying around. So we can't use this internal shrinking process. If only we had a way of going back to the choices that led to the value. Then we could do the shrinking that we want. So Harry wondered if bigenerators could fill that gap. And I was like, I think so. So we got right to work. So here's our setup. Remember, we've got our user-generated value. We want to unpack the choices that led to it, shrink them, and then regenerate. So we have a shrunk example that has the correct structure. here's how it worked. So you can imagine this is that big user JSON file, and you can see the by generator might unpack the first bit into these choices, and then a couple more choices might relate to the next part, and so on, and so on. In other words, yes, it worked. Also, not only could it unpack choices that led to a value, a user-produced value, but also if you had a lot of choices or a lot of inputs, it could unpack that into sort of weights of making those different choices. And that meant that you could regenerate lots of similar values. So this meant we could recreate the work of a paper called Inputs from Hell, which is all about making similar test cases. And we actually generalized their work because they did grammar-based generation and we were monadic. In fact, there was a lot more that these, and we called them reflective generators, could do, because every time we went to go tell people about this, they're like, oh, can it do this? And we were like, probably, and the answer was normally yes. So if I had a holy value, so you see this undefined, it will fill the hole with an appropriate value, so you see it's chosen a correct value between 1 and 10. It can do the parsing of randomness, say all my random choices are leaves, it's going to make me a leaf. It can do the opposite, so it can unpack the choices that we've labeled that led to a value. It can do weighted generation, or it can invert the weights, so this one's going to invert the weights to desperately try not and choose a leaf, but eventually it is going to have to choose a leaf. So you see it's got 4, 3, 2, and 1, all within the bounds before eventually it chooses the leaf. And it can also do enumeration. We even got the Distinguished Paper Award at ICFP 23. Yay! But do we stop here? People normally stop here. Yes, we're in 3D now, partly to symbolize our realization that we should not stop here, partly because Bitmojis are now in 3D and I wanted to reuse those slides. But it's all symbolic, it's all symbolic. And I think it was said quite well earlier. Are we doing research to publish papers, or are we doing research to solve problems? You know, we did it, we wrote the paper, but were we solving a real problem? So separately, Harry and I realized that this should not be the end. We realized we shouldn't just pat ourselves on the back and go, ooh, we did a nice, lovely, cute solution. You know, we gave it to the reviewers, they were like, oh, it was cute, and then we presented it and everyone's like, oh, that was nice. If people can't use it, that's meaningless. So we want to make sure that generators, or reflective generators, are usable. So we now went our separate paths to realize this. So Harry went to investigate the usability of property-based testing and generators. So he did a user study at experienced users of property-based testing in Jane Street. And he found that in practice, writing generators was really hard. In fact, users said it was the biggest annoyance of trying to use QuickCheck. They said it was tedious and high effort. So certainly he discovered we were not done. So he joined a growing movement uniting PL researchers and HCI, or human-computer interaction researchers. And there's this really excellent blog post here that's called PL and HCI Better Together that summarizes why this is a dream team-up. So I really recommend scanning the QR code and then reading it on the tube on the way home. And in the meantime, I'll give you, it's going to stay up, don't worry. I'm going to give you a little summary of what they said. So I wanted to pass on their main point from this blog post. And that was both of these communities have a lot to learn from each other, which they summarized into this table. Let me focus on the first one. Last chance to scan the QR code for your travel reading. So one of the things that we thought that we could learn from HCI was picking good problems. And I think that's been mentioned quite a lot today. You know, what is impactful research? And the HCI people, they're really good at this. Because not only are they really good at finding good problems to solve, but they consider what they call these need-finding studies as a contribution in itself. So it's actually a publication that they create while finding this. And as a whole, that leads to a lot more high-impact research because you know what problems are out there and finding the problems is valued. Meanwhile, back to me. So I read this paper, A Case for Feminism in Programming Language Design by Frohlich Hermans. And it also advocated for human-centered PL. So through the lens of feminism, this paper highlights that currently quite a lot of the research that published is research that is considered hard. And only publishing hard things kind of gives us a skewed view of programming languages at PL conferences. You know, we really want to have a diverse amount of research. So the example that she gives is, for example, user studies on programming languages often go to software development conferences. And that means that the PL venues don't get to see kind of what happens to the language after it's been created. You know, we've got a smaller view, and some of what's definitely PL research ends up at non-PL venues. So quite a few of what this paper said struck a chord with me, and I was motivated to keep the conversation going, but also switch from problem identification to solution. So supported by VeTSS, thank you, and also risks. So we heard from Lizzie earlier from risks. You know, the socio-technical cybersecurity, they know what's up about thinking about the humans. So helped by these funding bodies, I helped organize an event focused on this paper. And at the event, we started a lot of fruitful discussions, and I wanted to honor that event by continuing these discussions here. Yes, we're building up to the audience participation. Brace yourself. But of course, all of my examples here were very programming languages, very testing focused, because that's my home. But this is quite a diverse audience. We've had, you know, AI talks, verification, security, people from industry. So I want you to consider now, and I am going to pause for like a whole 10 seconds. So please do think about this. Think about how the things that I've said, you know, PL, only publishing hard things, think about how that might apply in your work. That's your 10 seconds. So for example, next time you complete a project, we completed our project, our distinguished paper, make sure you ask yourself these questions. Have you considered the user? So for example, in security, as we've sort of heard, it's pretty vital that your lovely security system that you've made is actually usable. You could write this most secure thing in the world, but if no one can deploy it, that doesn't, you know, that's not what we want. And we heard from Lizzie earlier more about the accessibility of security solutions. The next question I want you to consider is, have you considered the non-technical impact of your work? So I think it's really important to consider the value beyond technical hardness. So usability is one example that I've given, but what else should be considered? Okay, it's discussion time. So I've timed my talk, so we have about 10 minutes. And instead of you asking me questions, I was going to ask you questions. Because the main thing we found from the Value in Feminism event was we kind of need to decide what we value. So these are my questions to you. What kind of work is currently valued and why? What kind of work do you think we should value and why? And how can we change the value systems to support that work? So I had some thoughts while I was listening today. So we had the VETS problem book, which is a really good idea of saying we value this sort of stuff because we are going to fund that. Yeah. Any thoughts on maybe the first question first?
Okay, coming up. Too late now. I saw the hand.
So at work, we design programming languages, and one of the common frictions I find is I want to build something, beautiful and mathematical, and so do my colleagues, but we can't build software no one will use because that doesn't make any money. And a common sort of vibe check we do is, what are the sharp edges on the design of this? Where is a non-expert user going to get confused? How can we document it? And it's normally a fairly secondary discussion. We struggle a bit with that. Are there good ways to, apart from thinking about it at all, which is maybe we're doing great by considering this even remotely, are there better ways to structure thinking about this sort of thing from designing a language as the goal?
I was meant to be asking you questions. I think that's why we need to team up with our friends in other fields, because I don't know. Because potentially, so I'm just finishing my PhD, so I took all the papers I've had, none of them have really had human-centered stuff, because I was like, I need to finish my PhD, so I'm going to do what gets published. But now I want to start asking different questions. But that's a good question.
Can I answer the opposite question? I can tell you something.
What don't we value?
Something that's not valued is work on maintaining and sustaining tool chains. So I think Rob Ashmore was saying he wants to keep things running over decades. A fun bit of stats you can do is you take the tools section of one conference and you measure how long the tool has existed before the paper, how long it exists afterwards. Awkward.
I think that's a good point, thank you. I think it's again with the theme of what happens after the language gets created. Thank you.
So joining both of those things with both the question, and I also don't know, but I know people who know, so ask me. And then the tool maintenance question about whether it's valued or not. But also the difficult, like somebody recently asked me, what is the hardest part of what I do, which is formalize complex proofs on cryptography. And I said, it's talking to cryptographers and convincing them that this language is actually necessary, right? That it's not just necessary for trust, but that the complexity of the tool is necessary given the complexity of the objects we're looking at. And understanding, and this was me convincing them, and I would like Simon, a bit more insights on how I can understand them as well.
Yeah, thanks for a great talk. Coming back to two, I'm here.
Oh, sorry.
I found also that maybe there's papers publishing ideas, and then there's work that's more focused on building a tool. And sometimes when you're building these kind of tools, you get questions like, okay, but what's the key idea? What's the problem you're trying to solve? And sometimes the work is just so technically difficult that it's hard to convey, and it's hard to. I feel like sometimes this work is not valued, even though it's valuable for the community. Since you have this beautiful idea, you need to make it workable for possible users, but this bridge itself is sometimes not seen as valuable to publish. That's something I found.
Maybe more of a comment rather than, or an answer to question 3 in some sense. So I think a large problem that we're dealing with, what you're trying to solve, is that human beings do not like change, right? It's as simple as that. So I mean, from my area, I can tell you, so we've been trying to convince numerical programs to use something better than Fortran, and they say that Fortran is the best language. We don't need anything else. And I've seen this many times. I've tried to convince people using Git because CSV, CVS is crap. They don't want to, and I think this is why we have the value system as we do. So the answer to question 3, you have to change the human nature, but this is very hard.
That's why I keep talking about it.
Sam, thanks for giving this talk and asking these questions. Just on point 3, about picking up on what the gentleman said, I think value systems are encoded in the culture of different conferences. So, Popl has a sort of sense of what a Popl paper is, or maybe ICSI has got a sense of what an ICSI paper is. And that's pretty hard to change. Like I was a PC chair at Popl, I know other PC chairs at Popl, and you can say what you like to a committee, but people feel they've got expertise in what, say, a Popl paper is, and much less expertise in, say, I don't know, software engineering. So when it kind of comes to the crunch, and papers are, you're trying to figure out which one, what gets in and what gets out, people have less confidence about, say, HCI methods or whatever, and so those papers don't get in. I literally can think of conversations like that where people go, oh, none of us is really confident. In principle, we'd love to have an HCI paper at Popl about programming languages, but we don't feel confident enough. We need to keep up the standards of Popl, so we won't take it. So it doesn't get in. Whereas something that is clearly very mathematical and there's theorems, blah, 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 is much easier for a committee to accept. I think that's really hard to change. One thought is to co-locate. And, effectively, you've got multiple committees, but they're at the same venue. And so that way you can get more papers from a diversity of methods as you're advocating. And hopefully people mill around and go to different conferences. Places like ETAPS are like that. I don't know if they particularly, in fact, they do have some software engineering papers as well. But maybe spoken too long, but that's one thought about what we can do to change the culture.
Yeah, I was just reading the summary of the workshop we had, and some of the ideas were similar to that. Start small, don't go straight to Popl, but build it up nice and slowly. Or we could have like workshops that we share ideas with HCI people. We've gone, we want to do this, how do we do that? So we could ask them, and then we could be educating PC members. This is what this should look like, and stuff like that. I believe we have 2 minutes left, if you agree. So did you have a question?
No, he said.
Oh, perfect. Anyone else in the last couple minutes? Should I finish early because we're running behind?
Unless you've got some final thoughts, we can stop here.
No, thank you very much for listening, and thank you for contributing.
Thank you.